Hey math kids, today we're going to talk about true bearing. We are in, chapter 7, section F. And before we start example 11, I just want to read something that's in the blue box. It says true bearings are measured clockwise from true north, and they are always written with 3 digits plus decimals if necessary. So true north is just going to be straight up. And then depending on where we're at, we always start at true north and go clockwise. So we go this direction as we're measuring. Another thing to keep in mind is that a line is 180 degrees. That's going to be helpful on these problems. Okay, so example 11. When Samantha goes jogging, she finishes 2 kilometers south and 3 kilometers west of where she started. Find Samantha's bearing from her starting point. Okay, so we just pick right here is her starting point, and she goes 2 south. If we're thinking northeast, southwest. So we go down 2 kilometers, and then she turns and goes 3 kilometers, and this is her finishing point. This makes a right triangle, obviously. Now, what we're interested in, though, is we want to know her true bearing. So basically, if she was at start and she rotated towards the finish, how much would she rotate? Now, when we're doing that, we think of true north, and we rotate all the way around like this. Now we know that first piece, so the part that I'm marking in pink, that's going to be 180 degrees. So all we really need to do now is figure out what this theta would be. Luckily, we have right-angled trigonometry that we can fall back on, or SOHCAHTOA. And we have opposite and adjacent, so that's a tangent. So we can say tangent theta equals opposite over adjacent. We use inverse trig, so inverse tangent, those cancel. And we're left with theta equals the inverse tangent of 3/2. We go to our calculator. Make sure you're in degrees for this, so we'll say second, or sorry, just mode. You don't have to hit second. Mode, go down, change it to degrees, and then we typed this in. So we have second tangent 3 divided by 2, hit enter, and we get 56.3. So 56.3, that's our 3 digits using a decimal as necessary. And that was just the theta, so we also need to add 180 to that. And so we have 236, that's our 3 digits, and that's our answer. Okay, now we're going to move on to example 12. And it says a courier departs from his depot A and drives on a 136-degree course for 2.4 kilometers to an intersection B. He turns right at the intersection and drives on a 226-degree course for 3.1 kilometers to his destination C. Find the distance from C to A and the bearing of C from A. Okay, so there's a lot going on. So we're going to read it one piece at a time and make a diagram. So we start at A, and then we go to B, and they tell us that that is 2.4 kilometers. And they also tell us that it's a 136 degree course. So what that means is if we look at true north, if we rotate from here to here, that's going to be 136 degrees. Okay? If we continue to C, so this is B, he turns right at the intersection and drives 226 degrees. So once again, that is measured from true north. So this is 226 degrees. And goes 3.1 kilometers. And then we'll just connect this and go back. Okay, so a couple things that we need to look at. So if we're going to go A, B to N, we rotate and then we go 180 degrees because of the line. So we have, yeah, so we're just going to say, where is it? A, B, N equals 180 degrees minus 136. And so that angle is going to be 44 degrees. So that angle right here, that is 44 degrees. Now, if we go A, B, C, so this angle, I guess I gotta get a new color. So the angle from here to here, so A, B, C, we can see that that's a full circle if we use the pink, the blue, and the green together. And so if we just want that piece, we just subtract those out. So we start with a circle, we subtract out the 44 that we just found, and we also subtract out the 226, which is the blue one, and we are left with 90 degrees. And so we know that this is actually a right triangle, and that's going to help us. Okay, now we want to know the distance from A to C, and so the way that we do that is we just use the Pythagorean Theorem. We have a right triangle, so I can even just simplify that. So we have a right triangle that looks like this, and we want to know this side. So it's x squared equals 3.1 squared plus 2.4 squared. Bring up our calculator. Do that side, 2.4 squared. Okay, we get 15.37. So we have x squared equals 15.37. We square root both sides. So square rooting, you can also raise to the 0.5 or the 1/2. And we ended up with 3.92, and that's kilometers. Okay, so that's the answer to part A, which was the distance from A to C. So I guess I'll just say AC. Okay. Now it wants us to find the bearing C from A. So essentially what that's asking is just what is, or we need to care about theta, sorry. The bearing is the entire thing. True north all the way to here. Once again, if we start at A, we rotate clockwise until we're facing C. That tells us the bearing. Like that. And so to do that, we can just use right angle trig. Once again, we have a right triangle. This is 2.4, this is 3.1, this is theta. Opposite adjacent means tangent. So tangent theta equals opposite over adjacent. We do the inverse tangent of both sides. Theta equals the inverse tangent of 3.1 over 2.4. So we say second tangent 3.1 divided by 2.4, and that's 52.3. Now remember, that's just this piece, so we also need to add 136 to that. And that's 188.25, but it's just 188 because a bearing only uses 3 digits. Alright, if you need additional help, please come to Math Lab, and for now, calculator.